getting back to arrays, right? So arrays, you're talking about arrays in programming. It's actually a very crucial concept, right? So you're talking about the efficiency of arrays. Arrays are considered efficient in several ways, particularly in terms of time and space complexity. So time efficiency is actually the access time, right? How efficient it is in the terms of the access that it gives, right? So first is time efficiency. Let me just rewrite this thing, right? Right. First is time. Right. So time efficiency, arrays are very time efficient. The access time is O1, so the access time is very less. So arrays allow for constant time access to any element, which basically means you can retrieve or modify an element directly using its indexed. So this is because arrays are stored in contiguous memory locations. So the memory address of any element can be calculated directly from its index. For example, accessing the fifth element in an array takes the same amount of time as accessing the first element, right? So that's why it's very efficient in this time management. Then we have sequential memory access. Due to their contiguous memory allocation, arrays benefit from better cache performance when data is stored sequentially. So the CPU can load, or it can try to load multiple elements into cache at once. So it can store cache. It can store the values in its cache at once. So it speeds up the time delay or the time speeding up the access and the processing times, right? So you don't have to load it every time. It will be stored on the cache. Just you need to access it, right? Then we have space efficiency, minimal overhead. Arrays have minimal overhead compared to other data structures like linked list or hash tables. The only memory used is for the elements themselves, and in some languages a small amount of additional memory for storing the array size, right? I think the microphones is a little, might need to adjust it. Just a minute. Right. Perfect, I guess, yeah. Yeah, so you're talking about space efficiency, right? So space efficiency is something which is very important, right? So there's very little or minimal minimum overhead in arrays. So arrays have very minimal overhead compared to other data structures like linked list or hash tables or anything else for that matter, dictionaries even. Sorry, yeah. So the only memory used is for elements themselves, and in some languages a small amount of additional memory is used for the storing the array size, but not in all languages. Then you have the fixed size for static arrays, because static arrays are of a fixed size. They do not require additional memory for dynamic allocation or pointers. They can lead to more efficient use of memory in situations where the maximum size is advanced, right? So this is one of the provisions. Space efficient arrays are space efficient, very space efficient, right? Simplicity, we already talked about simplicity, right? It's very simple, and it's giving very low overhead in operations, right? The efficient iterating over an array is very efficient because elements are stored in a contiguous memory, which reduces the number of instructions the CPU needs to execute. Operations like summing all elements, finding the maximum or minimum, or applying a function to each element are optimized due to this memory structure. Right. So then we have efficient sorting and searching. Arrays are very particularly suited to sorting algorithms like quicksort and megasort, which can take advantage of the efficient access and compact storage. For example, binary search on a sorted array is extremely fast with a time complexity of 0 log n, right? And one of the major reasons of arrays is also the predictable nature. Arrays is very predictable. Right. There is a very predictable memory usage since arrays use contiguous memory locations or blocks. The amount of memory they use is very predictable and very, kind of, you can say, you can know what the array will do, making it easier to manage and optimize resources, especially in systems with limited memory. So there is a constant time operations. Many operations on arrays such as element access or setting a value, or something like going through the elements, iterating through elements, have constant time complexity O1 or ON, or traversal, making performance predictable and easy to optimize, right? So it's optimized for, you can say, low level operations, right? So compiler optimizations are very heavily optimized, Arrays can be heavily optimized by compilers because they are such a fundamental data structure, which is good actually. This can lead to faster execution times and reduced resource usage, especially in performance critical applications. Alignment and padding is also one of the features. Arrays allow compilers to align data in memory optimally and reducing the need for padding bytes and improving the efficiency of memory access, right? Then we have use cases where array efficiency shines. Graphics processing, we have graphics processing where arrays are particularly used to store pixel data in images or frame buffers, where fast access to each pixel is critical. Numerical computations in scientific computing, arrays are used to store large data sets like matrices, where operations such as matrix multiplication rely on efficient access patterns, right? Then you have data streaming. Arrays are used as buffers in data streaming, where quick and sequential access to data is needed. While there are many limitations, arrays are highly efficient in the aspects mentioned. As I've told you already, they do have limitations there, such as the fixed size in static arrays and the costly operations of inserting or deleting arrays, or the elements, which may involve even shifting elements, right? So, in situation where the flexibility of frequent resizing is required, other data structures like dynamic arrays, linked arrays, or hash tables may be more appropriate, even though they might need or they might incur more overhead. They are more suitable compared to arrays because it's just very simple, right? So this is one of the point which is a limitation of array. Then we have some organization, how they are done, and we know they are very efficient due to their predictable memory usage and fast access times and very minimal overhead. Their efficiency makes them ideal for a range of applications, especially when the size of data set is known in advance or when fast sequential access to data is required, right? And organizing the organization of arrays in programming, we mainly focus on how arrays help in structuring and managing data in a way that makes it easier to store, access, and manipulate data. This organization in itself is crucial for developing efficient and maintainable code, right? So first, the reason is how you do things is very important, right? More than doing things, it's important how you organize things to go back and to find things that you have done, right? So you write a code, you need to know where what is stored so that you can structure it nicely, right? So that's where array are useful. So it can help in structuring and managing data, which makes it very easy to store and access and manipulate things. Similar to how you do in folders, you create Windows folders, right? let's say you have a song folder and it is separated by the albums or the artist, right? So it is kind of similar to that. So this organization is crucial for developing an efficient and maintainable code. The structured data storage that arrays have, so the structured data storage that array has is very important. Right. So how array was built is actually arrays allows us or allow data to be stored in a structured and orderly fashion in a manner which is by organizing this data into a sequential structure, it makes our job easier, or arrays makes it easier for us to manage collections of related data. For example, data grouping. Similar types of data like a list of numbers, names or objects can be grouped together in an array. So this keeps related data in a single place, reducing clutter and making the code more readable. Right? Consistent access patterns with arrays, the access pattern is consistent. Right, that is one of the major advantage of it. With arrays, the access pattern is consistent. Each element is accessed using an index, making the retrieval process straightforward, uniform across the entire array. So, structured data storage, you can say, one of the reasons it is used is data grouping. And consistent says that's right. Now we have consistent access patterns. It's like arrays help us the access patterns to make it consistent. Each element is accessed using an index, like to access the index 0 index 2, the element is first element will be given to us, right? Making the retrieval process very straightforward and uniform across the entire array. Whether it's very big or whether it's very small, it does not matter at this point, right? Then we have simplified data management, right? It's very simple and the data management is so simple and so naive that it's very easy for beginners to do it. Right. So we have index-based access, right? So The thing with arrays allows us to allow very easy management of data through index-based access. This, in layman terms, it means you can quickly retrieve, update, and iterate over data elements without needing to transfer complex structures as you might do in linked lists or trees or dictionaries or anything else, right? Then you have something called order data. So order data is arrays inherently maintain the order of elements as they are entered. This makes them ideal for situations where the order of data is important, such as in time series data, right? Or in time or anything else. So implementing algorithm that requires sorted data, arrays are very good or very important for usage, right? Then we have efficient memory usage, which is actually we've already talked, right? But this comes also under organization. So array organizes data in contiguous memory locations, which I already told you about many times before, right? But it not only organizes or optimizes memory usage, but also improves performance. So this organization is very beneficial in memory locality because arrays are stored and accessing sequential elements tends to be faster due to better cache utilization, and this leads to fewer cache misses, right? And overall faster processing, compact representation. Arrays do not require additional memory for pointers or reference, as in with case with linked list, making them more efficient and when storing large amounts of data. Ease of implementation. Next point in our list would be ease of implementation. It's very easy to implement it, right? For algorithms, it's very easy to implement arrays. Many algorithms are easier to implement and more efficient when using arrays because of their organizational properties. Sorting, searching with using algorithms like quick sort, merge sort, and binary search are straightforward to implement on arrays due to their ordered and index-based structure. Arrays have a matrix-like representation, right? Arrays can represent complex data structures like matrices, 2D arrays, which are essential in mathematical computations, graphics, and machine learning. Then we have something which is consistent data handling, right? So consistent data handling is also very important in managing arrays. We have homogeneous data. Arrays are typically used to store homogeneous data of the same type, right? Which ensures consistency in how the data is handled. This is particularly useful in operations that require uniformity, such as batch processing or vectorized operations. Batch processing. Arrays are ideal for batch processing tasks where the same operation is performed on all elements. Their organization, the structure allows for these loop-based operations, making it easy for us to apply functions or transformations across the dataset. Right? Simplifying debugging and maintaining is also one of the main features of arrays. So basically, in a nutshell, I would say arrays are used for simplified nature, for the simplified structure, clear structure. The clear index structure of an array is what makes it easier to debug and maintain code. When something goes wrong, or it's very easier to trace the back problem to a specific index or element because the structure is very clear. It's a simple line, right? Then you have predictable behavior. Arrays behave predictably, making it easier to anticipate or to get things right. How changes to the data will affect the overall program. This predictability reduces the likelihood of getting something done, right? It reduces the likelihood of bugs and makes the code more maintainable over time. Then there's some versatility across domains. Data buffers. Arrays are always commonly used as buffers in networking and data streaming, where they temporarily hold data before it's processed. They organize structure ensures that data is processed in the correct order. So this is how buffering is done using arrays, right? So it's versatile, right, across domains. Then you have lookup tables. Arrays can be used to implement lookup tables where the index of the array corresponds to a specific key value, allowing for fast retrieval of information. They are foundation for complex structures, complex data structures, building blocks. Arrays serve as the foundation for more complex data structures like heaps, queues, stacks, hash tables. Understanding how to organize data in arrays is crucial for implementing these more advanced structures effectively, right? The organization provided by arrays is a key factor in their effectiveness, which makes it a very easy and dense data structure for simpler programs, even for complex programs which needs a simplified structure, a simplified approach. So they have a structured, consistent and efficient way to store and access data, right? Which enables arrays enable programmers to manage large and complex data sets more easily. This organized approach, this organized way simplifies this coding and debugging and maintenance, which makes array a fundamental tool in the programmers that build, like the Batman build, right? So always know that it is fundamentally very important to understand these complex yet basic things. They may look basic at first, and honestly they are very basic in structure, but they are used to create something very extraordinarily, right? Very extraordinary things. So most I have seen this not as only in programming in my area, years of career, but also elsewhere, that most complex things are made up of simple structures. Even we as human beings are made up of simpler beings, simpler cells, right? So most simple things uh, come up together to create these complex structures, these complex beings, these complex softwares. So you need to understand these simple things to make up this complex structure, right? So always try to go through this and understand it carefully.